Hi, everyone. Okay, let's do another fairly quick example, but one that really gets at that idea of the definition of sine and cosine. So we want to imagine we're on the unit circle, we start at 1, 0, and we travel 3 units counterclockwise around the outside of the circle. And then we want to try and state some things about where we're at. So again, you'll see me draw these constantly. I think the picture is really helpful. 1, 0 is a good starting point. That would be standard position. And counterclockwise, that's nice as well. That's the standard direction that we go unless we get a negative angle or arc length. So we're going to go about 3 units. And there's this funny thing that happens in people's brains. We get so trained to think about multiples of pi or fractions of pi that when I give you plain old 3 units, very commonly one of two things happen. Either people get really confused and aren't even sure quite how to tackle that, or they just mentally attach a pi to it and they're thinking 3 pi units instead of 3 units. So remember that pi is a number and it's roughly 3.14. So don't forget to, yes, give me exact answers, but also remember the approximates. It can help you make sense of things. So if we went a full pi units around the outside of the circle or rotated through a full pi radians, we would end up over at negative 1, 0. We haven't quite gone a full pi units, but we've gone close, right? So this doesn't have to be perfect. This is just our visual. But I'm going to imagine I've traveled that far around. So I'm landing at this point just above the x-axis, and I can't tell you exactly what those coordinates are, but I can say that I'm in quadrant 2, which is one of the questions that was asked. So that's in quadrant 2. And then if I needed to find my x coordinate or my y coordinate, I could use my sine and cosine function. So this is really their job. So we don't want to forget this. If I needed to find the x coordinate, cosine, I would plug in 3. And if I needed the y coordinate, I would take sine and I would plug in 3. So this right here, this is the exact coordinates of that point. So of course, again, we can use technology to get estimates, but this is not a bad answer. I would say cosine of pi isn't a great answer because you should be able to tell me what that is. But cosine of 3 is a great answer. You don't have to round, and there is no nice exact answer. So I kind of want you to think about this in the same way we think of square root of 16, not a simplified answer. But the square root of 15, that's perfectly good. I can't do better than that unless I switch to an approximate answer and lose some information by rounding. Okay, so let's look at the estimating with the calculator part as well, though, so that you can find those approximate values. For one thing, you can use that Desmos link that you see right there just to play around and see where that's at. But do also make sure that you know how to, using some sort of calculator, just plug that straight in, cosine of 3 and sine of 3. So I'll show you in Desmos. The way this is going to work throughout the quarter is you're going to have some tests that are no calculator so that I can see that you're getting the memorization part for the exact values. And then you'll have some tests that allow calculator. So just make sure you're thinking about both parts of this. Okay, so I'll go in Desmos and I'll show you with the demonstration, and I'll also show you how you could just type that in. Maybe. There we go. Okay, so in the demonstration, you could, here, let me, oh, it won't let me expand a little to show you this. Hold on. There we go. Okay, so we could drag this around. A is like our t value here. I don't know why it's labeled A, but that's our t value. So we wanted to go, let's see if I can get it, to exactly 3. And that actually gives you the coordinates. So you could take it straight out of this, but you won't get to use this on a test. So just to be sure, so feel free to use this on your homework, but also make sure that you know how to plug this in. If you don't have a calculator, when you get to tests that allow them, you can borrow a scientific calculator when you come in. But if you have your hands on a scientific calculator, it's nice to be able to use one that you're familiar with. Okay, so what we want to know is for the x value, what is cosine of 3? And let's just check here. If you go up to the graph settings, notice at the bottom it says radians or degrees. And I don't know if I set this to default to radians or if it always does, but check that. If you're just jumping in to Desmos, make sure that you're set in radians. And then I can do the same thing. I can type in sine of 3. So in Desmos, you just type that in exactly. On scientific calculators, you should see sine, cosine, and tangent buttons. And then eventually we'll also want to use the inverse sine, inverse cosine, inverse tangent buttons. So I'll mention those when we get there. But you do want to be able to get approximate values as well as exact, even though we're going to focus a lot on exact right now. Okay, so back in there, negative 0.99, 0.141. Okay, so this is exact. That is exactly the coordinates of that point. No error, no rounding. And this is approximate. So approximate can be incredibly useful, but I always want you to be aware that you are losing a little bit of information when you round. It's not perfectly true anymore, but it's close enough to true for most purposes. Okay, thanks for watching.